In the 1930s, a Bell Labs technician named Karl Jansky was using a crude antenna to track thunderstorms and other natural sources of radio waves that might cause telephone interference when he stumbled on a signal from an unknown source in the sky. He spent years tracking and studying the mysterious hiss, observing it travel from horizon to horizon each day and wander as the seasons change. Eventually, he concluded the hiss was coming from very far away, the center of the Milky Way galaxy. We now know he was tracking the black hole that resides there. Jansky's discovery sparked astronomers to build better radio receivers, giving us clearer and clearer pictures of the radio sky. Similar to how infrared goggles give one a whole different view of our world, radio telescopes act as radio goggles for the night sky, allowing us to see our universe as never before. By 1959, astronomers had made another realization. While you can't create a light bulb that will stand out against the sun from light years away, you can make a radio signal strong enough to be noticed on a distant star. If other intelligent life exists in the galaxy, those aliens could do the same. But after 60 years of searching, we haven't found a definitive alien radio broadcast. Now, we might not be looking hard enough. We also might not be looking at the right thing. Radio seemed like the only choice for interstellar communication until recent decades. Today, laser technology is rapidly replacing radio, with NASA leading the charge. Lasers have many advantages over radio, particularly for astronomical distances. While both transmit via photons, a laser beam does not spread out as radio does, requiring much less energy to transmit the same information to a point in space. And while many natural phenomena emit radio waves, natural lasers are quite rare and do not flicker on and off as an alien signal encoding a message might. Most importantly, with current technology, we can make a laser that easily outshines the sun at the directed point. If we detect a flickering laser signal, there will be no ambiguity of whether it's alien or not. Many believe this is where the search for ET life should focus, and efforts to look for these signals have started, but these too may turn up empty. While currently the latest and greatest, laser communication may not be the terminal solution to long-distance communication. In another 100 or so years, we'll likely be using radically new technology, and would assume alien civilizations are using the same. Even if alien civilizations did broadcast with radio and lasers during periods in their technological evolution, it would almost certainly fall on deaf ears, as our respective technological periods would not likely overlap. And that's assuming alien civilizations would even want to contact us. Some believe technological civilizations would want to keep to themselves, lest they attract the unwanted attention of a superior civilization bent on their destruction. The dark forest hypothesis. I, however, think there's another reason civilizations would neglect to broadcast their existence. We assume an alien civilization would have the same questions about their existence as we do. They too would want to know if they're alone in this universe. And what better way to see if you're alone than to yell out and listen for a response? But what if you already knew you were not alone? The incredible images from Hubble and James Webb telescopes can give the false impression that we know all that lurks in space. We can see large structures with ever more clarity, but what we can't see is vast. Even in our own solar system, we've seen but a small fraction of the objects out there. Luckily, we can see and track most of the potential Earth-destroying objects, but those smaller or further out escape our detection. Many think there's even a whole planet lurking out there in the darkness, eluding our vision. And astronomers are fairly sure there's a cloud of more than 1 trillion objects, some kilometers wide, circling the outskirts of our solar system. But we've yet to detect a single one. There could literally be a gigantic alien structure lurking in our solar system, and we'd be none the wiser. Historically, most scientists didn't view this as a realistic scenario. Interstellar distances seem simply too vast to traverse. But in the last decade, we've made discoveries that make travel between stars within a human lifetime potentially feasible. Projects to blast small unmanned probes to 25% the speed of light with lasers are underway, with the goal of sending millions of these probes to our nearest stellar neighbors. If such a future is on our horizon, one must assume technologically superior civilizations have already done this. They should already be here, silently keeping tabs on us. And if so, we'd have no way to tell. But that will soon change. While instruments like the James Webb Space Telescope are amazing at capturing distant objects, the field of view is very narrow. You need to know exactly where to point it. Great for looking close up at known objects, but horrible for finding an unknown alien probe in a sea of empty space. For that, you need another tool, and it is being built. Astronomers are affixing the world's largest digital camera to the telescope at the Vera C. Rubin Observatory in Chile. Once fully set up in 2024, the Legacy Survey of Space and Time will begin. The telescope camera setup will start capturing images of the full night sky. These images will be produced every 3 days for 10 years straight. These periodic captures of the entire night sky will highlight all the small changes that occur, the elusive, interesting phenomenon that go undetected because we can't yet look everywhere at once. These images are also the first sensitive enough to detect many of the smallest and most far-out objects in our solar system. It's expected the number of identified objects in our solar system will grow by 10 to 100 times. It will also find objects with interstellar origin. Interstellar objects were thought to be quite rare until the first was discovered in 2017. Since then, 3 more have been found, 2 of them by scouring old records. Now, scientists think the Vera Rubin Observatory will find around 5 interstellar objects per year. The increase of apparent abundance in interstellar objects may be due to theories of solar system formation being off. Or it could be because aliens are aiming their probes at us. And while Vera Rubin will find these interstellar objects, it may still be hard to tell what the object actually is. To see any details, we'll need to send a spacecraft to take an up-close picture. And that's exactly what is planned. Projects like Comet Interceptor will send probes in Earth's orbit, waiting to take off and investigate interesting objects. Soon, when something strange is detected in our solar system, we will get a closer look. If there are alien probes lurking here, their ability to hide is going away. If and when they finally find one, we'll have that answer we were seeking. No, we are not alone in the universe. With that answer, would we continue looking randomly in the sky for alien signals, occasionally shouting at the stars? Or would we focus our investigations closer to home, examining what we discovered and looking in our own backyard? The same is likely true throughout the universe. First contact happens through letters, not phone calls. The paper that kicked off the search for extraterrestrial radio signals back in 1959 ended with these words: "The probability of success is difficult to estimate, but if we never search, the chance of success is 0. The search continues." Thanks for watching Rather Be Squidding. If you enjoyed this content, please like and subscribe for more.